Hi everyone, I hope that by this time you have completed lesson 1. So for today's lesson, we are looking at lesson 2 for topic 4.3 networks and decision mathematics. So as you can see here, for the learning outcome, we are still under the subtopic of trees and minimum connected problems. So we are still looking at minimum spanning tree, but then previously we are solving all the question by using a network diagram. So for today's lesson, we are going to look at how can we apply Prim's algorithm in a distance table. All right, so I'm not going to go through the learning outcome again. It's basically the same like what we have done previously. So trees and understand trees and spanning trees. Then after that, how to identify your minimum spanning tree and apply it to a problem that involve minimum spanning tree. All right, so before we move on for the distance table, let's do a very quick recap for the thing that we have learned in a previous lesson. All right, in the first class, we learned that the minimum spanning tree is the spanning tree in a connected weighted graph that has the minimum total weight, right? So spanning tree is a subgraph of a graph that is a shape of tree, and then you do not have any cycle in it, and you involve every vertices in the graph. All right, so I hope that you still remember that. So there are two algorithms that we learn how to determine a minimum spanning tree, which is the first one, which is the one that officially stated in the syllabus is called as the Prim's algorithm. So we always remember this algorithm as a method of choosing the vertices. So you start with any vertices that slowly branch out your spanning tree by looking at which one is your nearest neighbor, so-called. All right. And after that, the second one, we also know how to use Kruskal algorithm as well. So for Kruskal algorithm is much more direct. So everything that you try to do in all the steps is just choosing the edge that give you the minimum weight. So that's why this algorithm is also called as the method of choosing the edges. All right, so for today's lesson, we'll be looking at distance table, and we will be looking at how can we apply Prim's algorithm in distance table. All right, so we know that previously in our first lesson, when we try to apply the algorithm, we always apply it on a network diagram. So which means that you are given the graph, so you can look at how all the vertices are connected to each other and also what's the weight on the edges. Am I right? So, however, sometimes the graph that we are dealing with, right, can be a very dense one, which means that a graph with a lot of edges and vertices. So in that case, you can realize that no matter which algorithm that you are applying, it's going to be much more difficult for you to identify the nearest vertices or like the shortest edges, right? So that's why the information will be displayed in a much more organized way by using a distance table. So you can imagine if let's say we organize it on a distance table, but if let's say we want to find the minimum spanning tree and we still need to draw the network diagram, then it will be losing the meaning of organizing your information in a distance table, right? So that's why it will be easier that we know how to identify a minimum spanning tree directly from a distance table without needing to look at the network diagram. All right. And what a distance table is, if you can recall from the last exercise, you can try to look at your previous exercise, the last question. So I believe that you remember that there's a question that need you to transfer the information from a table onto a graph. So that table is basically the distance table that we are referring to. All right, so that's the idea. So it's not the first time that you have this distance table already. It's something that very similar to adjacency matrix, but then we are just putting in the information in a distance table. And for today's session, we are going to look at how can we straight away find out minimum spanning tree without drawing the network. All right, so before we look at the steps for applying Prim's in a distance table, let's recall the steps in Prim's algorithm first. So remember that Prim's algorithm is the method of choosing the vertices, right? So step one, what we try to do is we choose any vertex to start. All right, and what we have found out in our previous lesson is that no matter which vertex that you are starting off from, at the end you are still going to get the same solution. So that's why you can pick any that you want. All right, so among all the adjacent vertices, you are going to find out the vertex that is with the minimum weight. Alright, so when you are choosing the adjacent vertex that give you the minimum weights, at the same time, you always make sure that there's no cycle is introduced. Reason being is we want to find out the minimum spanning tree without having any unnecessary edges involved, right? So after you're having this, so this is an algorithm, so it's like a repetitive routine. So we are just going to repeat the same step until all the vertices in the graph are included in the tree. So basically, this is what we are doing for Prim's algorithm in a network diagram. So remember this routine, and when we talk about distance table, actually the idea is just the same, but it's just that there are some more small steps that you need to do when you are dealing with distance tables, so to avoid something that is very obvious in the network diagram, but then it will be kind of complicated when you are looking at a distance table. Okay, so you might want to follow this very closely up because for this step, it involves, 3 steps for 1 step. So that's why I wouldn't like split this table into, 7 tables. Then after that, we do it one by one. Then it will take a lot of pages as well. So that's why I will just do everything in one table here, but just follow closely because the step will be just repeating also. All right. So same thing, remember the first step is to choose any vertex within the network as the starting point, right? So it's the same thing like what we have done previously. Okay, but because we are looking at a distance table, so that's why when we are trying to find a network point, which means that we are trying to find out a column to start with. Okay, so step 1, remember draw an arrow. So I try to put an bold here so you can remember it clearly. The 3-step repeating will be arrow. Okay, that's the first one. Okay, second one, because we want to make sure that there's no cycle created, you can imagine if let's say I choose A here, right? It will be very clearly in my network diagram that I know that I'm not going to come back to A again. But then if let's say we are looking at the distance table, right, sometimes when we are trying to find out the adjacent, so it will be very difficult for us to avoid cycle, or you might always want to remember that you cannot choose A. So that's why the easiest way to avoid creating any cycle is to straight away cross the whole respective row to reach A. Alright, or it's like strike through the respective row. So first step, arrow. Second step is to strike through the respective row that you have drawn an arrow. Alright, third step, so we know that for all the adjacent vertices, what we try to do is we want to find out the vertex with the minimum weights, right? So in our network diagram, normally what we try to do is we try to connect it straight away, connect it to the one that give you the minimum weights. Okay, so in our distance table, you cannot draw like A to B, something like that. Then you can imagine it's going to be very messy, right? So what we try to do is we try to circle the one that we are choosing. So that's why circle. Okay, then at the end, we try to repeat the 3 steps. So just remember the 3 bold words here. The first one, draw an arrow, strike through the respective row, then after that, circle the one that gives you the minimum weights. Okay, so we'll start with looking at the distance table now. Alright, so same thing, maybe we will start from point A also. Okay, so vertex A. So when you have choose your vertex A, so this is where you draw your arrow. Okay, all good so far? Okay, after you draw your arrow, so second step, remember strike through. So you already connect A, so that's why you are not going to go back to A anymore. So that's why I will strike through the whole row for A. Okay, so just strike through. If let's say you are having your highlighter, then just highlight the whole lah. Okay, so which means you are not going to go back to A anymore. So that's the idea. Okay, third step, remember circle the adjacent. Okay, circle the minimum weight for your, so you can see that in your column A, right, there's only 2 numbers, which is 11 and 12, that is adjacent to B and C. So that's why this is what it is shown in network diagram, right? So to B is 11, to C is 12. So that's why between 11 and 12, so obviously 11 is the minimum. So that's why I'm going to choose B. So that's why you are just going to circle the 11 here. Is that all right? So 3 steps, arrow, strike through, circle. Okay, So after you circle, then you repeat the 3-step again, arrow. But where you want to put your arrow is the one that you circle. So you are going to circle at 11, which is adjacent to B, right? So that's why now the two vertices that you are looking at will become A and B. So that's why you add one more arrow at B. Okay, so this is what happened when we are doing a network diagram also A and B. You are going to look at both A and B now. But at the same time, you do not want to create any cycle. So you don't want to go back to B anymore. So remember your second step just now, after putting an arrow, strike through, right? So that's why B you also don't want, so strike through. Okay, so now continue. By looking at network diagram, you'll be looking at the one that is adjacent to both A and B. So same thing, you are going to look at all the number that is adjacent to A and B. So 12, 7, 22. So you see, it's the same thing, 12, 7, 22. All right, so in distance table, so between these three numbers, which one give you the minimum? So 7. Okay, so that's why, again, circle at the minimum. All right, so if let's say we are trying to put in a network diagram, then it will be like this one. Okay, so same thing, after you finish the third step, which is a circle, then go back to the first step again. So you already choose 7, so which means you want to involve vertices C. So when you involve vertex C, then which means you are going to draw an arrow at C. So now you involve C already. So you are going to look at all the one that is adjacent to C, but before you do that, remember, you don't want to go back to C anymore, so strike through the column for C. Okay, and remember this one also. Okay, so reason being is, you see, by looking at your network diagram, you doesn't want to choose the 12 here anymore, right? Because that will forms you a cycle. So that's why when you strike through, remember, strike through everything in the row. Okay, so now the 2 steps already completed. You draw an arrow, then you strike through. Then after that, now same thing, you are going to look at the one that you have in this 3 column. So 22, 16, 21. Which one give you the minimum? So 16. So as y, circle. Okay. So as you circle, remember you are choosing D. So that's why arrow at D. So arrow at D, then remember strike through D. Okay. So that's the idea. So if let's say we try to look at the network diagram, then it will be like this. Okay, so when you continue from there, then all this number is the one that you are having a choice, like which one to choose from. So that is correct, right? Why 12 is not in? Because you are not going to do a cycle. So the one that you are left with, 1, 2, 3, 4, 5. So that's why you have 5 number, 1, 2, 3, 4, 5, which is all correct. Okay, so now next one, same thing, you are going to circle which one is the one that with the minimum. So 7. So that's why, again, circle. Okay, so after you circle, then which means you pick F to involve. So that's why you are going to involve the vertices for F. So when you involve vertex for F, then remember cross off your F. Okay, so remember the strike through is not following the sequence. It's just nice that the one that we found just now is like A, B, C, but D. Okay, but now we are going to pick F, so that's why the one that you strike through, you are not strike through F, but you strike through F. Sorry, you are not strike through your E, but then you strike through your F because you already pick F to involve and you do not want to make any cycle at F. All right, so now continue. So you are looking at A, B, C, D, and F. So which means 1 number, 2 number, 3 number, and 4 number. So that's why that's 4 number here. Okay, so this is correct as well because when you look at your F here, okay, right? So you have 1, 2, 3, and then 4. That's the 4 number that you're having. Why 21 is not in? Because that will form you a cycle, right? So that's why 2, 8, 12, and 8. Which one is the smallest one? Then depends on you which one you want to choose of because you have 2, 8, right? So it's the same thing when you are doing it in a network diagram, then you have 2, 8 to choose from as well. So if let's say I want to make it like more organized, then maybe I'll choose E. Okay, so after I choose E, same thing, I pick vertex E. So that's why arrow at E, then cross off E. Okay, so I'm not going to referring to the network diagram anymore. So now just look at this one. Okay, so you can see that there's no number for A, B, C already. So that's why we are just going to look at the E, the D, E, and F here, which we draw an arrow at. So 12, 10, 10, and 8. So that's why minimum at 8. Okay, so after you choose 8, so it's from vertex G. So vertex G, draw a arrow, then strike through G. Okay, then continue. So now you have 10, 9, and 7. So the minimum one is 7. So after you choose 7, then you know that you want to involve I in your next observation, right? Then you do not want to create any cycle, so strike through I. All right, then after that, you see that you only left with H, so which means that this is the one that you didn't connect yet in your minimum spanning tree. So that's why between these three number, then it will be 9, the minimum one. So that's why after you finish 9, then H is involved already, then you just finish off everything. All right, so that's the idea. So what is the minimum distance that you will be having here? It will be 11 plus 7 plus 16 plus 8 plus 7 plus 8 plus 9 plus 7. All right, so when you are trying to calculate the number, remember, so A, B, C, D, E, F, G, H, I. So there are a total of 9 vertices. So how many edges that we have? 1, 2, 3, 4, 5, 6, 7, 8, which is correct. All right, because you know that the number of edges included will be exactly one less than the number of vertices, right? So that's why the thing here is correct. So 18, 34, 34, 34 plus 8, 42, 49. 57, 57 plus 16, that's going to give us 73. Okay, so this is correct. So when you're trying to look at this one, if you want to continue, then you know that you are going to choose the 2, 8. Then after that, Prim's algorithm, so 7. And then the last one is the 9 here. All right, then you realize that these 8 edges are basically the one that you choose here. All right, so I'm putting the network diagram here is just for your understanding where what you are doing in distance table is exactly the same like what we are doing in network diagram. So in the real question, so you might be having a question that only give you the distance table without giving you the network diagram. So that's why don't have the do not have the thought of like, if let's say the question give me network diagram also, then I just straight away do it here. Why do I want to make it so complicated? So the idea here is that if let's say this is not given, then you are going to have this only. So you are not going to spend time in your exam to actually draw the actual diagram. So that's why you will need to know how to apply it in a distance table only. So that's the idea. All right, so this will be your answer, which is 73, which is correct. All right, so now we'll be looking at two more examples. So I understand that this might be a little bit much more tricky compared to the network diagram. So that's why I'll try to explain it again and again. So for 3 times. So if you think that you already get the idea from the first example here, you can just pause the video. Then after that, try out these two examples and see whether you can get the answer or not. If let's say you are able to do it without my guides, without my instruction, again without my repeated instruction, then you can feel free to try it out by your own. So if let's say you're feeling that it's still a bit confusing for you, then just try to continue to watch it. Then after that, just try out different two more example here. All right, so yeah, let's look at example 1. All right, example 1. So this is the same example like the in our first handout as well. So this is the one that you have different buildings in a university. Then after that, the maintenance team want to find out the minimum spanning tree so that they can cover the path that the students can able to connect to every places when it's raining lah, right? Okay, so this is a distance table here. So I'm putting in the network diagram here is just for your reference. So I hope that when you are doing it in a distance table, you will be able to relate it to a network diagram and to understand that everything that you are doing are basically the same. So that will be much more helpful for you to understand the thing that you are doing. So that's why you are not like trying to memorizing the step. All right. Okay, but remember the 3 things that I said last. So the first one, arrow. After arrow, strike through. After strike through, then pick the minimum one. So this thing just continue to, repeat it in cycle. Okay, so the first one, so same thing, we try to pick any one that you like. So maybe in this case, we try to pick anything. Okay, so maybe in this case, we start from N1. All right, so just to prove that you can start from anywhere. Okay, so if let's say we start from N1 and we doesn't want to go back to N1, right? So cross strike through everything in N1. So we are going to look at those adjacent to A and 1. So we have 200, 180, 190, 350. So that's why 180 is the minimum. So which means in this case, we are choosing N2. So when we choose N2, so arrow at N2, then strike through N2. Okay, so now we are going to look at the column with N1 and then N2 lah. So 200, 190, 350, 220. So minimum 190. And now we are picking N3. So that's why arrow at N3, we involved this already. So that's why we are not making any cycles. So strike through N3. So now all the number here, 200 and 350. Okay, so there's nothing at N2 and N3 anymore. So that's why we only have 200 here. Okay, so to go to 200, then which means that now we connect to C. So arrow at C, and then we are not creating any cycle back to C. So strike through C. Okay, so now we are looking at the column N1, N2, N3, and also C. Okay, so N2, N3 don't have anything already, N1 still have 350, but it's larger than the previous one. So that's why here the minimum one is 190. Okay, and we are connecting to S1, so that's why arrow at S1, and I doesn't go back to S1 anymore, so strike through S1. Okay, so now looking at looking at C, S1, N1, N2, and N3. So the minimum that we are having is 180 here. So which is from S1 to S3. So S3 is now involved, and then we are not going back to S3. So cross off everything here. Okay, so now same thing. C, S1, S3, N1, N2, N3, and the minimum here is 190. So 190 connect to S2, so that's why we choose S2, and we are not going back to S2, so strike through S2. Alright, so now continue. C, S1, S2, S3, N1, N2, N3. So the minimum 350, 400, 350, the minimum is here. Okay, so 270 go to E1. So E1 is now connected, and then we don't want to go back to E1. Okay, so now you have one more column, which is E1 here, and the smallest here definitely going to be here lah. 180 go to E2. So that's why we pick E2. Then after that, no more connection to E2. Okay, so yeah, there's nothing left over here. You only left with 400, 350, 390. So the minimum one that you will be having is here. Okay, which connect to W1. So involve W1, strike through W1. So minimum here is here, 180, connect to W2. So involve W2 and no more going back to W2. So you can see when you have everything strike through, then which means that you already finish off everything, because you don't want to create any cycle back to everything here, which means that you already connected to everything lah. So that's why it's basically the end for your process. So that's why you can realize 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10 edges and 11 vertices, so which is correct. Okay, so now the minimum distance, let's try to add them up together. So 200, 350, 190, 270, 180, 190, 180, 190, and 118. Alright, so you can try to just use your if you want to practice your what is that called, your manual calculation also can just, you know the last number is 0 lah. So 20, 35, so 55. So 55 plus 19 is 74. Okay, so 74, 74, 101, 101, 119, 119, 137, 156, 156, 156, and then 174. So 174, 174 plus 19, and you got 193, 193 plus 18, and that's going to 19318. So 211. All right, so this is correct. 2110 and meter. All right, so you might want to just look at your distance table, then maybe you try to label it in a network diagram and see whether you get the same thing with your previous handout. You will realize that the answer is the same. So 200 is C to N1, so C to N1. Okay, then after that 350 is W1 to C, W1 to C. Okay, and then C to S1, C to S1. Okay, then after that W2 to W1, W2 to W1. Okay, 190 here is S3 to S2, S3 to S2. Okay, then next one, S3 to S1. Okay, 180 here, N1 to N2, N1 to N2. Okay, and next one is N1 to N3. All right, the next one, E1, C1 to E1, C to E1. Okay, then after that, last one, E1, E2. All right, so try to compare this highlighted one with your previous handout. So you'll realize that you get the exactly same minimum spanning tree. So that's why your answer here, they are all correct. All right, so that's this question. I hope that by now you have an idea for how to work this out already. So yeah, if you can, so try to go through the second question and see whether you can try to do it by yourself or not. If no, then after that, you continue to watch this video again. All right, so let's look at example 2. All right, question 2. So this is the same question as well. So you just want to connect the electricity to 8 different sites in a part. All right, so you want to find out the least amount of electric cable that you just need to use to connect all the electricity. All right, so am I having I'm not sure whether you have this doubt or not, like whether do we need to start from the source, then after that to make sure that at least we have one connection, right? But no worries about that, because remember that when we talk about minimum spanning tree, you will stop until you connect to every vertices in the graph. So that's why it doesn't matter that whether you start from the source or not, but at the end of the day, you will have at least one side that connect to the main sources of the electricity source. Then you no worries about that, because as long as you have P involved, right? And spanning tree we talk about, you must include every vertices, right? So as long as you include electricity source, I mean once, even only once, you can also connect all the electricity for every 8 sites as well. All right, so now same thing. Let's try to just look at the distance table, then understand from that. So same thing, you can try to pick anywhere that you want to start off. Okay, so maybe in this case, let's try to choose, maybe we start from S1. Okay, so any place I want to start from P also can, just try to play it around. Okay, so same thing. You might having if let's say you choose a different one, then which means that the sequence that you are picking, the vertices will be different, but at the end your solution will be the one that you cycle will be still the same as well. Because remember what we talked about this. Yeah, so if let's say you started from different case, then the different vertices that you are going to pick. But then at the end of the day, the answer will just be the same. So no worries about that. Okay, so if we start off with S1, then which means the minimum. Okay, so remember, don't forget cross strike through, right? So you pick S1 and you are not going to go back to S1 anymore. All right, then after that, the minimum that adjacent to S1 is S2, which is 7. So you already pick S2, so that's why arrow at S2, then strike through S2. Okay, so now looking at the column for both S1 and S2, so the minimum is 8 here. So you connect to S3, so arrow at S3, then not going back to S3, so strike through S3. So column S1, S2, and S3, minimum is here, the 9 here. Connect to S4. So if you're connecting to S4, arrow at S4, strike through S4. Okay, so now this 4 column, so the minimum that you're having is the 10 here. So 10 connect S2 to P. So that's why P is involved now, and you are not going back to P anymore. All right, so now continue. So P, S1, S2, S3, and S4. So that's why the one that you are having here, the minimum is 11. So 11 connect P to S3. So S6. So S6 now is involved, then we are not creating cycle. So strike through S6. Okay, so now we have minimum here, 1, 2, 3, 4, 5, and also here minimum is here. Okay, connect S6 to S5. So S5 here, then strike through S5. Okay, so among everything, you left with 17, 16, 18, and 10. So obviously minimum is 10. So you are connecting to S7. So S7, strike through S7. Okay, and last but not least, you only left with S8 that you didn't connect yet. So which one is the minimum weight to reach S8 is actually the 8 here. Alright, so same thing, arrow at S8, then after that, not going back to S8 anymore. So now you have every vertices connected already and everything strike through, then you know your answer is correct. 1, 2, 3, 4, 5, 6, 7, 8. So 8 edges versus your 9, correct. 8 edges versus 9 vertices. So that's why this is correct. So just add up your answer together. So 11, 18, 28, 36, 45, 54, 64, yeah, 72. Okay, so this is correct as well based on our previous answer. 2, and this is this km meters. Alright, so that's the answer here. Same thing, if you want to check it out, is it the same with your previous answer? So feel free to just highlight it. Then after that, just check whether you have the same thing or not. So P go to S2, S1 go to S2, or S3, S2, S3, S2, and then S4, S3, right? So PS6, PS6. Okay, then S6 to S5, S6 to 7, and 7 to 8. Alright, so I believe that this is the diagram that we have highlighted previously when we are using our network diagram. Alright, so that's basically everything that I can see that every vertices here is involved. So I hope that this content wouldn't be like very hard for you. So yeah, just make sure that you understand, you don't confuse with it. So when you try to do it in sequence, then you don't left out anything lah. So make sure that you don't suddenly do your arrow, then suddenly you go and circle, then after that you realize that you didn't strike through, then it's going to make you very confusing. So that's why always remember, started off with arrow. So arrow, then you cross off the one that you put in your arrow, then after that you circle the minimum. So after you pick the one that you connected, then arrow at the one that you picked, then after that cut off the. So remember, always follow the sequence that arrow, then you cut off, then after that you do your circle. Then I believe that you should be all fine already. Alright, so if you're still feeling confusing or anything that you are not sure with, then feel free to just approach me. Alright, so that's basically for this question. So I hope that you can understand everything, and we'll proceed with the second application in the next week. Alright, so yeah, spend some time to do your homework. I believe that you can finish everything within 2 hours. Alright, so see you next week.